Hey everyone, welcome to my channel. Aditya here. We will continue our AWS comprehensive course. The next topic I am going to cover is Lambda concurrency. This concurrency will come into picture when you are invoking a Lambda, right? For example, I am invoking Lambda 10 times. Then Lambda will invoke 10 times simultaneously, and also these 10 invocations will be executed in concurrent. So that's where the concurrency come into picture. It's like execution of the Lambda instances in parallel. Okay. And if we invoke our Lambda function multiple times, as many times as possible, then all these invocations will execute concurrently since Lambda can scale very fast. Since Lambda has this fixture called scalability, if you invoke your Lambda multiple times, right, then all these invocations will be executed parallelly. But there is a limit on how many concurrent execution, that is 10 invocations. So AWS currently imposed a limit of 10 invocation per function. 10 invocations in the sense 10 concurrent invocations. For example, if you hit your Lambda 10 times simultaneously, then it can able to process. But if you hit the same one with 20 requests at a time, then it will fail to process those requests. So you need to keep in mind that there is a limit for these concurrent executions, that is 10. If your events are small, Lambda may execute 2 to 3 concurrent executions. So since your event is small, and in case of larger events, Lambda can scale up to 10 concurrent executions. So for example, you have 10 users and they are not using your applications at the same time. So they are using your applications once in a while, then it can happen 2 to 3 invocations. But if you have 100 users, they are simultaneously hitting your Lambda, then these 10 requests can be invoked at a time with 10 concurrent invocations. But your application can able to process those since Lambda has a limit of 10 concurrent executions, right? If those executions crosses 10 concurrent execution, then we will get into an issue. Okay, so even we can control our limit furthermore. Since Lambda itself by default given 10 as your reset capacity, but you can able to limit furthermore by using reserved concurrency. So Lambda is usually giving 10 as our concurrent executions, right? But if you want to limit this, for example, you only want to do only 5 concurrent executions, you can use this reserved concurrency option and limit your Lambda to only execute for 5 concurrent executions instead of 10. Okay, and where we can set the limit at a function level. So each function you can able to set reserved concurrency. By default it is 10, and you can able to set some reserved concurrency here. And so here there was an example. So for example, if we set reserved concurrency as 5, means this particular Lambda can execute 50 concurrent executions. Sorry, it's a typo, it's 5 concurrent executions. Okay, so if you set your concurrency as 5, then your Lambda can execute 5 concurrent executions. Don't get confused with concurrent and normal executions. You can hit your Lambda as many times you want, but you want concurrent, like parallel executions, right? Those can be done only 5 parallel executions or 5 concurrent executions. If any executions are more than 50, so here type it, if any executions more than 5, that means that is more than reserved concurrency limit. So here our reserved concurrency we set to 5, so that any execution which are more than 5, then we breached our concurrency limit, then Lambda will trigger a throttle. So remember, whenever you breached or you crossed a limit, then it is called a throttle in Lambda's terminology. So what is a throttle? A throttle means we exceeded the limit. So when you exceeded the limit, right, Lambda will behave differently based on types of Lambda invocations. So based on Lambda invocations, usually Lambda will behave differently. And when it comes to Lambda invocations, right, if you recall what we have discussed in the previous sessions, we have two types of Lambda invocations. That is synchronous invocation and asynchronous invocation. Okay, so based on the invocation type, for example, if it's a synchronous invocation, this throttle, right, during throttle, Lambda will behave in a different way. When it's asynchronous invocation, during throttle, Lambda will behave different way. So we'll look at it. Synchronous invocation, if you observe, right, in this case, if you have throttle, right, the Lambda will return throttle error. That is 429 series. Okay, it will return an error. But when it comes to asynchronous invocation, right, in this case, if you get any throttle, right, Lambda will try to retry automatically. And if any failures happen, then those failed events go to the dead letter queue for further processing. Okay, so that is the difference between synchronous and asynchronous invocation with respect to throttles. So that is how synchronous and asynchronous invocation handles the throttles. Okay, synchronous invocation is straightforward. It don't uh, do any retrace, it will directly return the error. But when it comes to asynchronous invocation, it will do a retry and check whether it can resolve those errors automatically. And if even though it failed to do so, it will store those events in the dead letter queue. Okay, so that is how the throttle will behave differently. And if you see the next point, if we want to reserve capacity more than 1000, so for example, previously the earlier version we used to have 1000 has the highest capacity, but the newer version usually having the 10 as the capacity, as we discussed in the previous slide. So the maximum capacity is 10, but previously we used to get 1000 concurrent executions. But yeah, just forget about these two zeros, just focus on only 10. So if we want the reserve capacity more than 10, then we need to contact AWS support team and open a ticket for higher limit. So if you want any higher limit than the AWS defaulted one, then you need to contact the AWS support team and open a ticket for the higher limit. Okay, now we're moving to the next part. With respect to Lambda concurrency, we have a problem. Okay, we'll look into it and we'll see how to resolve that. So earlier, if we don't set reserve capacity, right, reserve concurrent limit, right, then the following may happen. So we'll see what will happen. We have few users here, and these users making a request to the application load balancer, and the application load balancer invoking the Lambda instance. Okay, this is a single invocation. And after that, we have few users, and they are invoking application API gateway through which it is invoking a Lambda instance. Okay, so this is one invocation. And finally, the developers who are using SDK or CLA, they are directly invoking the Lambda. Okay, now if the first one has more users, right? If they start using, for example, you can see they have hit, for example, 10 requests, and again application load balancer hit Lambda for the 10 invocations. Now look, like this Lambda got invoked 10 times and it reached the concurrent execution limit. So just ignore here 1000, just keep in mind 10 only. And as I said earlier, previously Lambda allows to add 1000 concurrent execution as default. But now only we are going to get only 10 concurrent executions in the latest versions. Okay. So if 10 invocations happened here itself, right? And this user, right, try to invoke the Lambda through API gateway, right? If he tries, since already limit got breached, if he tries, he will get the throttle. Similarly, the developers who are using SDK and CLA trying to invoke a Lambda instance, they will also get throttle. Okay, because you have already used all the 10 concurrent executions which are by default Lambda provided to you. You have to set the reserved concurrency limit. So if you don't set, you will get into this issue. If you set concurrent execution to 5, then what will happen? Right, more users will try to access, but only 5 concurrent executions will only happen. Right, and also this user can able to do their 5 concurrent execution. So like that, we don't get into the throttle issues. So like that, we can resolve this Lambda concurrency problem. And moving on to the next topic, concurrency and asynchronous invocations. So we have discussed, right, how throttles behave with respect to synchronous and asynchronous invocations. Now how concurrency will work with asynchronous invocations we'll see, right? So for asynchronous invocation, I am taking the same S3 event notification example where we have an S3 bucket in which we keep on putting objects. For example, if I keep an object in the S3 bucket, a new event will be triggered and it will invoke a lambda. Similarly, another object and another lambda, another object, another lambda. Likewise, if you add 10 objects into this lambda bucket or this S3 bucket, simultaneously 10 lambda invocations can be happened, right? And what if it reaches the limit? For example, 10 concurrent invocation. What if it reaches the 10 concurrent invocations? We know it will throttle only. But how asynchronous invocations will handle that, we'll have a look now. If the lambda function reaches the concurrency limit, that means 10, right? In the newer AWS, they are only providing 10. If you reach the 10, right, then the newer event request after the concurrency limit are throttled, obviously, right? You reached already 10, and again you are putting some objects, and concurrent executions won't happen. You will get a throttle. So for any kind of throttling, for example, if you get some throttle error, for example 429, and any kind of internal system errors like 500 series, right, then lambda returns this failed event to queue. So it won't fail the event, right? It won't itself fail the event, but it will store that event in a queue and again retry it for up to 6 hours. Okay, so it will not fail the system. So asynchronous invocation not fail the system. But when it comes to synchronous invocation, it will directly return 429 error code. But asynchronous invocations, what it will do is it will keep the failed one in the event queue and it will try and retry it up to 6 hours. Okay, and this retry also will be done in a different way. For example, the retry interval starts from 1 second. Okay, you got a throttle and you retried. It took 1 second. And after that, after that first attempt, right, that will exponentially increase up to 5 minutes. So second attempt will be in 5 minutes, not next second, right? It will wait for 5 minutes and again it will retry. Like that, it will increase the time up to 6 hours. How many invocations possible it will try to invoke having some time interval, so that at one particular point of time there will be some invocation available for that particular event so that it can able to process. And even if it fail to process at that time also, then it will fail the particular event. Okay, otherwise it will maximum try its best to process that particular event. So this is how concurrency throttle, right, could be handled within the asynchronous invocation. Okay, we'll move to the next topic, that is cold start. So in Lambda, right, you had about this thing called cold start. For example, if you search for the Lambda cold start, also you will get so many blogs about Lambda cold starts. And by using provisioned concurrency, we can able to eliminate this cold start. So first we look at what are cold starts. Okay, whenever we are invoking a new Lambda instance, code need to be loaded, right? And code outside the handler, that is which was in execution context or initialization code, need to be loaded. Okay, so if you observe this point, if you take a lambda, we will have a handler function. Inside handler we will have actual lambda code what we are trying to use, but outside the lambda we have execution context, right, where we write our initializations. And that initialization code usually takes time, no? So whenever you spin up a new instance, it will take time to load those initialization, right? So if the execution context having HTTP, SDK, and DB dependencies, for example, like those initializations storing those information, then it will took more time to process. Obviously, right? For example, HTTP client connection took 1 minute, and SDK took 10 minutes, and DB connection took 5 minutes. Just hypothetical, I'm saying, and total 20 minutes are Yeah, Lambda won't live for 20 minutes, total 5 minutes, for example. Total it took 5 minutes to establish these dependencies in the initialization. Then it will take more time to process. Okay, so 5 minutes for initialization and some other time for processing the Lambda. Okay, so that the first request always takes time to load and subsequent ones will took less time as we seen in the execution context lecture. So if you follow my videos, right, you can able to see this execution context related course or lecture where I have shown in the hands-on lecture how execution context help us the subsequent request to lower its latency. Okay, but the first request has higher latency than the next request. Even though execution context helps in improving our lambda, but the first request always takes time. So this is called cold start. The starting of the lambda first invocation will take time because of some dependency initializations, whatever it will take time. So to eliminate this issue, we need to use provisioned concurrency. Since to avoid the above issue, what was the above issue? The cold starts. We can provision this concurrency in advance before the function is invoked. That means before invocation of our lambda function, we will make that function to be provisioned with concurrency. So if we do that, lambda function won't take that much time for the initialization. So before invocation itself, it will execute that lambda execution context and store that so that the first context or first request also will be executed in the low latency. So this will eliminate the cold starts and all the invocations should have low latency, including the first one. Okay. So to provision this concurrency, if you want to provision this kind of concurrency or provisioned concurrency, we can go to the auto scaling service, which is application auto scaling service, where we can manage this concurrency. It may be scheduled or target utilization. Okay, so where you can able to provision this concurrency for a lambda is application auto scaling service. You can use this application auto scaling service to provision your concurrency. And why to use this provision concurrency? To avoid or to eliminate the cold start. What is cold start? The first invocation of any lambda will took time, maybe for the initialization or loading the code, right? It will take so much time. So to eliminate that, you can use this provisioned concurrency so that you can able to achieve better performance. Okay, so that's it about the theory part. And we will move to the hands-on part and we'll see how to enable this concurrency and play with the numbers. Okay, I'm not going in depth in the hands-on this time. I'm going to show you where to configure the concurrency and what is the default concurrency and how to configure provision concurrency. These things I will show you. Okay. Now, I have opened my AWS account and navigated to my Lambda function. Earlier, I have created these Lambda functions. And if you don't have any Lambda functions, you create your Lambda function. And I hope you know how to create Lambda function. Till now, you've progressed from the course, right? We have created this Lambda function from scratch so many times. So now I'm going to open the test Lambda. This test Lambda I have created for previous lectures, so I'm going to show you how to configure concurrency here in this test lambda. So for that, once you open the lambda, you will get this interface, right? And in this interface, if you scroll down, you have this configuration section. Go to configuration section, and in the configuration section in the left side, you will have this menu. In this menu, you have a number of options like general configurations, triggers, permissions, destinations, like that up to so on. In the end, you will have this option called concurrency. Click on this concurrency, and in the concurrency you can able to see the two things what we discussed. One is concurrency itself and another one is provision concurrency configuration. Okay, and as I told, right, the unreserved account concurrency which was by default AWS is providing is 10. So one AWS function can invoke 10 instances. So 10 instances can execute in concurrently for a particular one lambda function. Okay, so you have one lambda function and you invoke that lambda function 10 times simultaneously, and the execution could be happened in the concurrency 10 instances, and more than 10 instances it will throttle. Okay, so here it is saying use unreserved account concurrency. So we'll go to edit and see. So here the unreserved account concurrency is 10. And here, right, as we discussed, we can able to do the reserved concurrency also. So your function is always throttled. If you keep 0, your function is always throttled. So we'll try to increase 1. It is saying the reserved, the unreserved account concurrency can't go below 10. Okay. So the unreserved capacity we can't go below 10. And this one, right, since it is showing 10. But if you open a request to the AWS team, they will increase this value based on our usage Lambda invocation. So they can increase based on quota. So since we are unable to edit this, because if you add any reserved concurrency, it will become the less than 10, then it is showing that error. So we'll make it 0 itself, right? We select reserved concurrency and save it. So since reserved concurrency is 0, so we are itself saying we don't have any concurrency. So we'll see how execution of Lambda will work, whether it fails or not, we'll see now. So for that, go to test. The test, right? Click on test. And here you can able to see it called failed because rate exceeded. Since you said 0, it won't work. Okay. Now go back to the configuration and change it to use the unreserved account concurrency, that is 10 concurrency itself, and save it. Okay. And the next one is the provision concurrency configuration. So we can able to provision the concurrency. So that is provision concurrency. And why we need to use the provision concurrency? To avoid the cold start of an lambdas. So here you have two options, like here you can able to add configuration, or here you can click on this add button. And here, right, you will get the configured provision concurrency page. In this page we will have options like qualified type. So here we have alias and version, and about this I'm going to explain in detail in the future lecture, and this time you just ignore these things about alias and version, and also these drop boxes, right, where these are basically, if you select alias related values will come here, and if you select version related values will come here. So I will explain these things about alias and version in the future section, and as of now just ignore, and you need to select one of them, either any one of them, and you can provision the concurrency value. Okay, if you provision the concurrency value, you can see AWS pricing will be increased. Okay, so as of now I'm not going to increase anything. Okay, I'm not going to increase anything, I'm just going to leave this field as is, but this is where you can increase your provision concurrency. And you need to work with AWS team to add more concurrent executions. As of now it is showing only 10 unreserved account executions, right? So you go to the AWS team and open a ticket, and they will add more concurrency to your Lambda, then you can use this provision concurrency. Okay, but as of now, since we are having only 10 concurrent unreserved concurrent executions, we are unable to add the value. And even if you add this value rate, you will get price, or you will get charged for that. So you can go here and check for the charges also. Okay, so this is the place where you can configure your concurrencies. Okay, I hope you understand how to configure that and how to increase this based on the service quota. Usually Amazon will increase it, but if you want more than 1000, right, I think up to 1000 they will increase automatically based on the concurrency, it seems. But if you want to more than 1000, you need to contact them and ask them to increase it. Or I'm not sure about whether we need to increase, we need to contact the AWS team for the 10 also to increase more than 10. I'm not sure as of now. But as I worked earlier, right, I remember only 1000. At that time the default value is 1000, not 10. So at that time we used to raise an AWS ticket to the AWS support team to increase from 1000 to higher value. But now it is only 10. Okay. So this is how you can configure your concurrency. And I hope you understand the concept. And thanks for watching my video. If you like my video, like, share, and subscribe, and let me know in the comments if you want to learn further more topics. Thank you.